After the interference, after the topic we are going to discuss about the after the interference, that is diffraction. Diffraction means in case of already we discussed about interference, whenever the waves, light waves are traveling from the certain distance and from the slits and superimpose on one another, due to that whenever they are moving in the some of the direction, they superimpose and forms a maximum intensity and minimum intensity, means dark bands and bright bands. So here the what is meant by the diffraction? Diffraction means the bending of waves when the obstacle is placed in the direction of in the path of the light. Means if in case of light is traveling in this direction and whenever the obstacle is placed in the path of the light, then the light, whenever it is incident on the aperture of that obstacle, then light bends towards the like this. Small deviation will be happens. That bending of light is called as a diffraction. Nothing but the bending of waves around the edges of an obstacle or aperture is called a diffraction. Means here when obstacle is like this, light is moving in this direction and instant on the obstacle, then light, some of the light bends at the edges of the obstacle. So according to this diffraction, some of the two phenomena, it is divided into the two types, of two scientists are classified about this diffraction, that is Fraunhofer's diffraction and Fresnel's diffraction. Means according to the first information give about the theoretical explanation given by the Fraunhofer's diffraction, whenever the source and the screen or the telescope which is viewed for the image from the lenses are used, it is when the both are placed at infinite distances, means Fresnel and Fraunhofer's in the diffraction, the source and the screen or telescope are placed at infinity or effectively at infinity, means large whenever the screen and the source is placed at infinite distances, then the wave will be plane wave front. The total light wave will be plane wave front. So that's why whenever already we discussed about that, whenever for the large distances every light wave front can be the plane wave front. So that's why whenever the source and the screen are placed at different distances, then here the wave front will be a plane. So that's why whenever it is an incident on the earth, then the edges will be in the form, means whenever light bends and diffraction phenomena will happen whenever the screen and source are placed at different distance, means infinity distances, then at the center of maximum intensity and minimum intensity of bands or fringes. Earlier in interference also happened that dark and bright fringes, like that in diffraction phenomena also maximum intensity bands and minimum intensity bands will be formed. If in case of, for example, if you take the torchlight, whenever you take the torchlight and you see the light passing from the light to the some of the distance, the light at the center will be maximum intensity, is having maximum intensity. It is go on moving into the edges, the light will be going to decrease, means the intensity of the light wave will be decreases. So that here is also light bends, whenever the light bends at the edges, whenever the obstacle is placed in the path of the light wave, then according to that, if the source screen are placed at the infinite distances, then wavefront will be plane. Whenever the wavefront is plane, when incident on the slit, then on the screen we can see the diffraction phenomena. So that according to that, the second one is Fresnel's diffraction. Later we will discuss about the fringes and also fringe widths also according to the single slit experiment in further class. So Fresnel's diffraction. Fresnel's diffraction is the source and the screen are placed at limited distances. At the limited distances, finite distances from the aperture, then the waves can be spherical, wavefront can be spherical or cylindrical. Spherical or cylindrical means if in case of slits, if we take that slits are placed, means slits having the distance, if the obstacle is small, then the diffraction will take limited diffraction will be happen in case of the obstacle is it depends on the obstacle is a small size or a big size, means a larger size, then it will happen the diffraction will be limited. So here it is that if in case of the large, then also we can write that like this, aperture will be whenever the diffractions will be happen like when at the edges, when the light is passing from this, then whenever it is incident on the edges of the slits, then the diffraction will be formed, means the bending of light, which is bending will be very small. So that's why the deviation of the light wave is very small. So that's why light bends at the edges. So due to this one, means diffraction, means due to the bending of light deviation, we can see that on the screen at the edges the minimum intensity of bands, at the center of the, due to the phenomena of diffraction, at the center of the screen, then we can see the maximum intensity band. So here it is that in case of here, when the source and the screen placed are infinite distances from the aperture, the obstacle having the sharp edge, when the wavefront may be spherical or cylindrical. Wavefront may be spherical or cylindrical, because of whenever they taken light waves are at small distances, then we can see the source. It depends on the source. If in case of for the larger distances, any source of the light, the wavefronts will be parallel, means plane wave. So here it is the applications of diffraction. Then what is the views of diffraction in daily life, where whenever in what concepts the diffraction is help for the life, means first the wavelength of X-rays. The wavelengths of X-rays are determined, means if in case of X-rays are more powerful, X-rays are more powerful, so that's why to find out to adjust the wavelength of intensity of X-rays by using the X-ray diffraction, and also we can see the grating. Diffraction grating means structure of crystalline solids are determined. If in case of crystalline solids, by using this X-ray electron neutron diffraction phenomena, then we can find out the structure of crystalline solids are determined. The next one is wavelengths of monochromatic or composite radiations, means either monochromatic light or composite radiations. We can classify it, the radiations can be measured accurately by using the concept of diffraction grating. The phenomena of diffraction grating, by using the diffraction method, then the wavelengths of monochromatic or composite radiations are accurately can be measured. The next one, the velocity of sounds in liquids. The velocity of sounds also by using the ultrasonic diffractions. By using the ultrasonic diffractions, we can find out that velocity of sounds also. And also in ultrasonic sound means whenever we are taking the scanning for the human body, whenever we are taking that ultrasonic sound, then that phenomena of diffraction will be useful for to know the size and shape of the ulcers, tumors which are in our human body. It will help in the scanning. The principle of diffraction, using in the ultrasonic scan. Whenever the light is traveling from this and it bends, then we can see the shape of the tumor, whatever it is there. So here it is that when the light is passing through it, and whenever the obstacle is placed, and the light deviates and bends whenever light is travels, and when obstacle is placed, light bends, the small deviation will be happen. So here it is that these are the applications of diffraction. Means once again, diffraction means the bending of light whenever the obstacle is placed in the path of the light, wherever that is traveling. Then here the bending of waves around the edges means whenever the obstacle is placed in the path of the light, then the light bends towards the edges of the obstacles. So that is called as a diffraction. The next it is divided into two types, that is Fraunhofer's diffraction and Fresnel's diffraction. In Fraunhofer's diffraction, the distance may be more, infinity distance. The screen and the source are placed at infinite distances, like if we see the telescope, from the telescope to know the stars, means whenever we watch that, then due to the large distance of the source, the wavefront will be plane. So here in the Fresnel's there is a finite distances, so that's why the wavefronts will be cylindrical or spherical. So that in that applications also, wavelengths of X-rays we can by using the X-ray diffraction, and the structure of crystalline solids are determined by using the X-ray and electron or neutron diffraction, and wavelengths of monochromatic or composite radiations can be measured accurately by using the method of diffraction grating. And the velocity of a source by using the ultrasonic diffraction. And in ultrasonic scanning, the principle of diffraction can be used to assess the size and shape of the ulcers, tumors, whatever the problems which is going to know this. Then in the human body, by using the ultrasonic scanning, we can find out by using the phenomena of diffraction. The next, earlier we discussed about the interference and also diffraction. Both are the similar cases, because of in the interference also there is a bright bands and dark bands are formed, and waves are passing and superimpose on one another. In this diffraction is also wave maximum intensity bands and minimum intensity bands are formed. Then what is the difference between the interference and diffraction? Difference between the interference and diffraction. Difference between interference and diffraction. Then what is the difference between interference and diffraction? Means we know that what is the difference, what is interference? Whenever the source is incident on the two slits, and from the slits the wave fronts will behave the source of the prior wave fronts will behave the secondary source for the next wave fronts. So that's why here we can say that the result, whenever in interference, the result of interaction of light coming from the different wave fronts originating from the source, means when the light is passing from that, whenever light is source is here, that this is the S1 S2, and whenever light is passing from that, then here due to the superposition of the waves, light band in the screen, dark bands, bright bands are found. So that's why here the result of interaction of light coming from the different wavefronts originating from the source, means here when the light is coming from this place, source, and when the light is coming from this place, and the S1 S2 behaves like the source for the secondary wavelets. So that's why whenever the light, result of interaction of light coming from the different wavefronts originating from the source is interference, and interference fringes may or may not be equal. Already we derived an equation before class, that is that fringe width, means here the interference fringes may be or may not be with having the same width. The fringe width also may be or may not be equal. It depends on that. So the regions of minimum intensity are perfectly black, means dark bands, bright bands. Already we discussed in earlier video. So in the dark bands, that is perfectly black. In the region of minimum intensity, we know the minimum intensity region will be means light intensity is less. So that's why there is a dark shadow is formed. So that is called a dark band. So the regions of minimum intensity are perfectly dark. So all bright bands are of same intensity. If we compare with this diffraction with the interference, then we can see this. When the result of interaction of light coming from the different wavefronts originating from the source, means here the originating from the source and the two different wavefronts are coming. But in this case of diffraction, then from same wavefront, from the different parts of the same wavefront, means whenever the light is passing from that, light is passing from the slit, then if in case of it is having the large distance, then source is coming from like this, then here we can see from the large distance, means here the distance is more, means D means the slit width is more. The intensity of here, the result of interaction of light coming from the same wavefront from the different parts. Here is the one of the part, here is different part, here is different parts. Means from the same wavefront, the interaction of light coming from the different parts of the wavefront. Means here the whenever the light is traveling from the same wavefront, means earlier we discussed about the torchlight. From the same torchlight, if we put the light, then we can see that at the center of the light is more intensity, which is having that surroundings light will be whenever goes on decreases. Intensity of the light decreases. So like that, here it is coming from the same wavefront, one wavefront, but the different intensity is more. Means at the center, the intensity will be more if we compare with the another regions of the light. So here it is that on the screen we can see that here the intensity will be more at the center of the light in the diffraction phenomena. So that the diffraction fringes are not having the same width, because of it is different, it is coming from the same wavefront. So that's why it is not having the same width. And also regions of minimum intensity may not be pure black, means light black can be, we cannot perfectly black, means here the sum of the light intensity will be happen. So that the different maxima of varying intensities with maximum intensity from central maximum, means if we vary this, the decrement of the intensity will be totally focused on the center. So that's why at the center the maximum intensity will be formed. So that the different maxima are of varying intensities with maximum intensity, with maximum intensity for central maximum, So this is about the difference between the interference and diffraction.